Alright, Chem students, this is Mr. Clark. Today we're going to be talking about periodic trends. Make sure you have your notes packet out and something to write with. Okay, trends and properties of the elements that follow a pattern down a group or across a period is what we're talking about today. Now, atomic radius is the first one. The group trend, atomic radius, will increase going down a group. That means as we add more and more energy levels going down, the overall atomic radius will get much larger. Now, going across, the atomic radius will actually decrease. This is not what you're expecting because as the atoms are getting heavier, they're adding more protons. This increases something called nuclear charge, which means the more protons we have, the stronger the pull they have, like a magnet. This will pull the electrons in tighter, which will actually shrink the overall radius. Now, ionic radius is similar. Positive ions are always smaller than the neutral metal atoms from which they are formed. When metal ions form, typically the outer energy level will be emptied, like we learned earlier. The metals typically don't have enough electrons to try to get to the next level, so they will lose that outer level. This will shrink them slightly, as you can see here with sodium. Now, negative ions are always larger than the neutral nonmetal atoms because they are actually gaining electrons. Their outer level has got more electrons in it than before, so they will increase slightly. So the group trend, ionic radius will increase as you move down a group. This is mainly due to the succeeding energy levels again. And for the periodic trend going across, it will generally decrease as you move across the period, and this is mainly due to the increasing ionization energy. Next trend is ionization energy. Now, ionization energy is the measure of how much energy would be required to remove an electron from the outermost energy level of that atom. Now, as a group, ionization energy will decrease going down. This is due to the shielding effect. The more and more layers of electrons we put around the nucleus, we lose some of the proton's ability to pull our electrons. So they're kind of shielded from the inner levels of electrons. The pull is not as strong. So that means it's easier for us, the more electrons there are, to steal one. It's like the nucleus won't notice because it has so many to worry about. Now, the periodic trend, ionization energy, increases going across the period. This is due to the nuclear charge. The more protons there are, the stronger the pull they have on those electrons, so we have to fight against that. As you go across, it increases, so the ones on the far right, much harder to take an electron from than the ones that are on the left. Electronegativity. The tendency of an atom to attract electrons toward itself when they're being shared. This means who has the stronger pull if they were playing tug-of-war. So oxygen here is sharing electrons with the two hydrogens, but oxygen is much more electronegative, meaning those shared electrons will be found much closer to the oxygen and further away from the hydrogen. This is because the hydrogens have low electronegativity. They can't pull as hard as the oxygen can. Now, as a group trend, electronegativity decreases going down a group. Larger atoms have more energy levels, so it's harder for them to attract electrons to the nucleus. Again, the shielding effect. Now, the periodic trend, electronegativity, will increase going across a period. That is again because of increasing nuclear charge. The more protons there are going across, then the stronger the pull. Alright, a fun way to explain electronegativity and ionization energy is comparing how easy it would be to steal an electron from a baby versus J.J. Watt. Now, obviously, to steal from JJ, you're going to need a whole lot of energy, maybe a brick or a 2x4. You know, it's just going to be very, very difficult to steal from an electron from any of the elements up in this corner. The baby is barely going to put up a fight. Another comparison is for ionization energy. If you have a baby and you're playing a tug-of-war with him, you're probably going to be pulling the rope much closer to yourself. If you're playing tug-of-war with J.J. Watt, he's going to be pulling the rope way more toward his end. Now, if the rope was an electron, obviously J.J. is going to have the electron closer because he's stronger. The baby, however, will not be able to pull it close to him at all. So to summarize, atomic radius and ionic radius will increase going down a group and decrease going across a period. Now, ionization energy and electronegativity will decrease going down a group and increase going across a period. If you can remember to write these trends down on your periodic table as soon as you get it, this will help you tremendously. You can look at this and realize when they give you two different elements, okay, from here to here I'm increasing, or from here to here I'm decreasing. Also, be sure that you can label and describe the following on a periodic table. What are groups and periods? Where are the metals, the nonmetals, and the metalloids? Which group has my alkali metals? Which group has my alkaline earth metals? Where are the transition metals? What are the lanthanides and actinides? And where are the halogens and noble gases?